b1 is the coefficient of y in the first equation, c1 will be the constant term. So here, see here, you can see that k is on the second term. So let us go for the first term. So as the system of equations are having infinity number of solutions, there is no need of steps, okay, because we are just doing all this thing in our rough area. So simply 2 by 4 is equal to, here the second one is 3 divided by k. Hold on, that's enough, because now we got an equation. Now while cross multiplying, you will get a 2k is equal to 4 3s are 12. Therefore k is equal to 12 by 2, and that's equal to 6, and that's your answer. So from this one you can understand that 6 is the answer, right? So we will say 6. So what is the option? Option number 3. Option number 3 is the answer, that is 6. So like this, very fast you will get if you know this one. So this is the condition given. If the condition given was unique solution, we will use this equation. And if the condition was given no solution, we will take this equation. So what is the hint given inside that one? From that one you have to choose the correct equation and just have to paste it. That's it. Hope you understood, right? Let's carry forward to the next question. Here goes the next question we told you. If AM is not equal to BL, see the condition? AM not equal to BL. Oh, that's a condition which we haven't written here, right? Let's go forward. Okay, this is a second question. So AM is not equal to BL. This is the condition given here. Then what else? Then the system of equations. There are two equations given. Let us mention them here. So these are the two equations given here. And this is the condition given. This is the condition given. These are the two equations. Okay. Anyhow, when you are bringing this into general form, this will be equal to 0. Here also you can wipe this off and you can put this here equal to 0. That means this will become minus. Here also it will become minus. Now it's in the standard form, right? You brought it in the standard form. Okay. Now, see, there are 4 options. What are the 4 options here? This system of equations, they are going to have unique solutions, or they are going to have infinity number of solutions, or they are not going to have any solutions, or may not be having any solution. These are the 4 options given. So actually, whatever we have studied about the conditions of giving solution or no solution like this, these are the conditions. But here you can see that it's not a fraction, right? But here you can see that everything which we have studied is regarding fraction. But here it is not a fraction. Let us bring it to a fraction. Actually, see, from this one, if you are considering, if you are relating to this equation, actually we have to find A by L and B by M, right? A by L and B by M, then C by N. That was the thing which we have to find. So from this one, is it possible to bring A by L? Yes. Bring this L to this side. So taking this condition here, I am just bringing this condition over here. So bringing this L into this side, already A is there. So by L is not equal to, here already B is there. Taking this M to that side, it will become divided by M. Yeah. Now that is the condition, right? A by L, B by M. And that is not equal to, it's already mentioned. That's not equal to. So which condition is this one? It's the first condition, right? A by L is not equal to B by N. If A by L, that means A1 by A2 is not equal to B1 by B2. If this is the condition, then what will be the answer? It will have unique solution, that's it. So we will go for the first choice. It will have unique solution, that's it. So that's why I told how much important that is. Now you understood, right? So that is the important factor which you have to keep in your mind. Keeping that in your mind, very fast you can come to this answer. Hope you understood, right? Okay students, so before going to the next question, let me just introduce one more thing. So here I told you about consistent and inconsistent solutions, right? So there we understood that there are 3 conditions that the system of equation may have solutions, may not have solutions, like that. So whenever you are trying to plot a graph from this given 2 equations, there are 2 linear equations. Using these 2 linear equations, if you are trying to plot a graph, there are 3 conditions for that graph. The first condition is that the graph can, I told you it's a straight line, right? It's already a straight line. They can intersect together. That's the first case. Then the second case is that if you're drawing the graph by using the equation, it can be like this also, that the first line will be a straight line. Again, the second line also will be on the top of that one. And that means it's overlapping. It's coincident. Means you can't see the second line because it's exactly on the first line itself. Actually, there are 2 lines, one above another. That's the second condition. And the third condition is that the lines may be passing parallel to each other. If you're taking this as line L and line M, here line L and line M, here line L is there, M is also there. So in the first condition you can see that the lines, they are intersecting at a single point, and in this condition we will say this system of equations, if you found that the lines are intersecting together in a single point, keep this in your mind, whenever the lines are intersecting there is a solution. Where will be the solution? Exactly at the point of intersection. Where they are intersecting together, exactly that will be the very correct point which is referred as the solution of that equation. So here exactly it is incident at a single point, right? They are cutting at a single point. So we will say this pair of equations are going to have only a unique solution. So this is the thing, unique solution. Something like this, right? This was another, and here we are coming in the graphical. This is the algebraic representation method, and here this is what we call the graphical representation method. That's the difference. So in algebraic method you will have to find the ratios, but in graphical method, definitely in the name itself it is there, right? Graphical method means you have to find the graph. So here from the graph one thing is clear, if they are incident together in a single point they will be having a unique solution. What about here? You can see that I told you when a line is incident above another line, when they are intersecting together, that point of intersection is what referred as the solution. So tell me whether this line is incident on another line. Is it intersecting on another line? Yes. Where? Everywhere. Not even on a single point, everywhere. Everywhere they are touching together. So in this case we can say there are infinite solutions. Infinite solutions means plenty of solutions. We can't count them, right? They are countably infinite, means we can't count and finish them. Plenty of solutions are there. That is the second condition. And in the third condition, I told you that line L and line M, they are parallel. They are parallel. They are parallel means they are not going to incident together. They are not going to coincide together. They are not going to intersect together. If they are not going to intersect together, what does it mean? It may not have any solution, because I told you where they intersect together, that point is what we called the solution. So being parallel lines, they are not going to incident together, they are not going to intersect together, and that's why we will say in this case, what will be the thing? No solutions. You are right. So no solutions. So these are the three conditions regarding graphical representation method. Keeping this into your mind, let us jump into the next question, question number 3. It's a statement and we have to watch the statement very carefully. Here goes the statement before you. If a pair of linear equations in two variables is consistent, listen to the word, if they are consistent, if those two equations are consistent, what should come in your mind when you're hearing the word consistent? Consistent means they are having solution. Consistent means they are having solution. So here the first sentence it's given like this, that the pair of linear solutions, the pair of linear equations are having a solution. They are consistent. They are consistent. Then the lines representing the two equations are. The lines representing the two equations are. Options are there before you. What is the first option? They are intersecting. Second one, they are parallel. Third one, they are always coincident. The fourth one, they are intersecting or coincident. Means they can intersect or they can coincide. Coincide means one lying above another. So tell me, for a condition of consistency, that means it should have a solution. It should have, that's all. It's not referred that it should have a unique solution or it should have plenty of solutions. It's that much mentioned that it must have a solution, that's all. It can be a single solution, mean a unique solution, or it can have plenty of solution. But tell me what will be the condition regarding graphical representation method. Here, is this consistent? Yes. Why? Because there is a unique solution. What about this one? Is it consistent? Yes. Why? Because they are also having solutions, infinite number of solutions. Is this one consistent? No. Why? They are not at all having any solution, as they are not intersecting anywhere. So we can say in these first two conditions, in these two conditions, that means that if a pair of linear equations should be consistent. If they have to become consistent, they can be this one or they can be this one. That means if from our options, which one we will choose? They can intersect or they can coincide. So fourth one is our option. They can intersect or they can coincide. Is that clear? So that's it. So here goes the next question before you. For what value of k do the equations 3x minus y plus 8 is equal to 0 and 6x minus ky plus 16 is equal to 0 are coincident? That means if these two equations, they represent coincident line. Coincident line means this one, right? Coincident line. You can see here the coincident line. That's the meaning, this one. So coincident line means one lying over the top. That means they are having infinity number of solutions. So that is the case. So in this case, we have to find the value of this k. So actually by drawing this graph, even though they mentioned about coincident lines, the thing is we have to do it algebraically, not by graphical method. So whenever they are saying this one, from this one you understood that this is the graph. That means the graph which is having infinity number of solutions. So let us climb to this portion. That means the algebraic method. So tell me, what is the condition for having infinity number of solutions? So here it is clearly mentioned a1 by a2 should be equal to b1 by b2 and that should be equal to c1 by c2, and that condition satisfies that those two equations are going to have infinity number of solutions. So in other way we can say that this question is actually they are asking that there are infinity number of solutions for this one, and in that case you have to find the value of k. So keeping that in your mind, this is the condition, a1 by a2 is equal to b1 by b2 and that's equal to c1 by c2. So here let us bring them together. What is a1 by a2? Tell me. Here it is, a1 is this 3, this one a1 by a2, b1 by b2, c1 by c2, right? So we can say a1 by a2 means 3 by 6 should be equal to b1 by b2 is minus 1 by minus k. Minus and minus, they will get cancelled together, or you can remove them, it will become plus itself. So keeping that in your mind. So what is k? Cross multiplying, you will get a, now keep this in your mind that this is 1 by k itself, okay? So keeping this in your mind, the first and the last one, 3 by 6 and 1 by k. Cross multiplying, you will get 3k is equal to 6 into 1 is 6. From this one, k is equal to 6 divided by 3 and that is 2. That is 2. So what is the answer? So here you can see there are 4 options given, 1 by 2, minus 1 by 2, 2 and minus 2. So this one will be your right answer. So this is the way how to understand a question. Means they are not giving straightforward, right? The question is not that much straight. They are just asking in another way. And when if you, that's why I told you initially that you must have this concept. If you got that concept in your mind, keeping those concepts, you can drag the question and you can place there and you can understand that this is the condition. But from that one, nothing to do with that one. So from there, we are jumping to this one, algebraic method, and we are considering that algebraic equation, we are placing it here. So in this method, you can understand that, and hopefully you will get it in. As I told you, you will get this answer within 1 minute if you are understanding the base of this particular theorem. Is that clear? That's the answer. So k is equal to 2 is the right answer. So we have studied about 2 typical methods. One is about the algebraic method to find the solution, and second one was the graphical representation method, and how to understand the graph and how to bring that to the 1 mark portions. And now, so most probably they will be asking these 2 typical types of questions regarding MCQ in this chapter. And there is also one more typical type of question that there is a possibility that that may also be asked in your examinations. So let us do that one question, and here goes the next question before you. The sum of a digits of a 2-digit number is 9. If 27 is added to it, the digits of the numbers get reversed. Find the number. So actually here a number is mentioned, it's a 2-digit number. Right, it's a 2-digit number. If you're adding the digits of that typical 2-digit number, you're going to get the 9 as the sum. Another thing, if you're interchanging the digits, means instead the place of, you are interchanging the digits of that places. If you're interchanging them, the number so obtained will be 27 more than the previous number. Right? Then you have to find the original number. So most probably there is nothing to do with steps and here and there. Let us do in the rough area work itself. You already know that if you are taking a 2-digit number, there is a ones place, that means the units place and tens place is there. Just let us imagine like this, for every number there is a units place and tens place. Let us imagine that the number in the digit in the units place is x and the digits in the tens place is y. So what will be the number? So whenever you are taking a number like this, it will be 10y plus x, right? Because this is in the tens place, this is in the unit place. That means if you are saying 24, what does it mean by 24? 20, 2 into 10 plus 4 into 1. That's what this value is, because 2 is in the place of tens and 4 is in the place of units. So 2 into 10, that is 20, plus 4 into 1, because 4 is in the place of units. So 4 into 1 is 4, and 20 plus 4, that's the value of 24. So whenever you are seeing a number like this, a two-digit number, this should come in your mind. The value of the number which is on the tens placement, it's not 2, it is 20, 2 into 10. And this value is just 4 because it's in the place of units place. Is that clear? So like this, I think you have studied this in our 6th and 7th classes about face value, place value and so on, right? We are just recollecting those things, that's all. So anyhow, here I told you that let this be the digits like this. The digit on the units place is x and the digit on the tens place is y. So the original number is 10y plus x. Keep this in your mind. That's the original number. So the number when reversed, that means if you are reversing this one, that means if you are bringing this x here and if you are bringing that y to that position, what will be that number? That number will be 10x plus y, right? The number when reversed. So this is the original number and this is the number when the digits are reversed. Keeping this in your mind. Now let us read the question. What was the question? What is the hint given inside the question? The sum of the digits is 9, right? The sum of the digits of the original number means x plus y, it is 9. That is the first thing. So we will write that one. X plus y, that's equal to 9. That is the first thing given here. That is the first thing. And what is the second thing given? And it is given like this, that if 27 is added to the original number, if 27 is added to it, if 27 is added to the original number, you will get the number in which it is reversed. Means you will get the digits of the number get reversed. If you are adding 27 to the previous number, so this is the old number, right? If you are adding 27 to this one, what you will get? You will get, where is it? This one, right? You are going to get this number. If you are adding 27 to this one, you will get this one. So let me bring it all together here. That means 10y plus x plus 27 is equal to 10x plus y. So from this one, if you are ordering them in the proper order, if you are bringing this 10 to this side and taking all these things, okay, you can rearrange like this. The equation will be like this. 10x, it is there itself. Bringing this x to that side, it will become minus x plus y is there. Bringing this y to that one, it will become minus 10y is equal to 27, right? What you done? You had taken this 10y to that position and taken this x to that position, kept both of them here itself. So 10x and this much is there. So 10x minus x is 9x. Here minus 9y is equal to 27. If you're cutting them short, x minus y is equal to 3 because all can be divisible by 9, right? So this is your second equation and this is your first equation. You got it. So now from this equation, even if you're adding the equation, even if you're subtracting the equation, you will get it because it's so simple equations. Let us add them together. Adding these two equations, 1 and 2, x plus x, you will get 2x. Then y and y, they will get cancelled because plus y and minus y is equal to 9 plus 3, 12. Therefore, x is equal to 6. You got the x value as 6. Now place this in any one of the equation. Keeping this in this equation, if you're placing this as 6, 6 plus y is equal to 9. Therefore, y is equal to 9 minus 6. What is 9 minus 6? It is 3. So you got the y value is 3. Now what will be the number? What is the number? The original number was, where is it? Yeah, here it is, right? This one was the original thing. That means 10y plus x was the number. So 10y plus x was the number. That means 10y, 10 into y, there is y. So 10 into 3, that is 30, plus x is 6, 30 plus 6, 36 is the original number. So we will choose 36 as the right answer. In the options, you can see option number D, 36 is the right answer. So that's it for today's class. And from this section, I hope that you understood this much. So only these 3 categories are given in this particular chapter. If you know all these things very carefully, you will never miss even a single mark from this question. I really tell you that you are not going to miss any single mark from this chapter. So these are the three different things which you have to keep in your mind while solving the MCQs of the lesson, linear equations in two variables. So that's it. We will meet again in the next video with a new chapter. Till then, take care and goodbye. Hi dear students, welcome back to the section of Mathematics of class 10. Today we are going to study the MCQ sections of the chapter Area related to circles. So dear students, regarding circles we already have studied in our previous classes. We know what a circle is and the total dimensions which is required so as to draw a circle is only a single dimension, and that is its radius. That means if a radius is given and if you have a center point, definitely you can draw any circle, right? That's the thing which we already know. There are two things which comes into our mind when we are studying about circles. Number one, the circumference of a circle. Number two, the area of a circle. What does it mean by circumference of a circle? Circumference, actually the point or the term, it means that the total perimeter itself. When we are studying about rectangle, when we are studying about triangles and square, means those particular figures we used to study about the perimeter. Here, as it is of a circular manner, we used to use the word circumference. So the equation to find the circumference of a circle is 2 pi r or pi d, because 2r is what we call the diameter. So taking that into concern, we can write it as pi d or we can say it as 2 pi r. Okay. Next thing, area of a circle. What is the area of a circle? Area means the total space included within the boundary of the circle, right? And that is what we call the area. And to find the area of a circle, we have an equation. Area of a circle is equal to pi r square. And the value of pi is 22/7. In some cases, we used to take it as 3.14. These are the general things which you already know. So today in this chapter we are going to study some new things. First one what we are going to study is the area of the circular path. If you are taking a circular path, for example, if you are taking a circle, just imagine that there is a circle like this. It's a bigger circle, and then again after this one you are considering a smaller circle within this one with a center. So just think that the radius of the smaller circle means from here to here, it is small r, because it is the radius of the smaller circle. That's why, just to understand that one, I took it as small letter r. And the radius of the bigger circle, this one, that is capital R. The bigger one r and the smaller one r. Now tell me, what about the area which is included between these two circles? Means, you know, if you are considering the area between this one, means this area, right? This part. If you are considering this much part, how can you understand that much? You have to do the area of the total bigger circle minus area of the smaller circle, right? If you are considering the area of the total circle, you will get the whole area. From that one, if you are removing this much part and throwing it away, if you are removing this much part, then the rest of the area will be this area which we needed, right? So that is what we call as a ring, or that is what is called as the circular path. So the area of the circular path or the area of the ring, we can say like that, the area of the ring, is equal to pi r square, the total area of the bigger circle, minus pi small r square. If we are taking pi into common, we will take pi into r square minus r square, capital R square minus small r square, right? So what is r square minus r square? Because a square minus b square is a plus b into a minus b. So you can write like this. If you are taking pi outside, you can take it as pi into capital R plus small r into capital R minus small r. So in general, we used to use that typical equation whenever we want to find the area of a ring or area of a circular path. Is that clear? Okay, that's the first thing. Next, the important thing which you have to understand about this one is what we call the arc. What is called arc? There are two typical types of arc. One is called the major arc. Second one is called the minor arc. What does it mean by major, minor? From the term itself, it is very clear. Major means the bigger one. Minor means the smaller one. Arc means it's the portion of the circle. It's not the total circle. It is a portion of the circle. Okay, it's a portion of the circle. So how can we consider that it is a major or it is a minor? I will tell you. If the total length of the circle or the arc, if the total length of the arc is greater than the semicircle. What is semicircle? Half of the circle, right? Semicircle means half circle. So the area of the total circle was pi r square. So area of the semicircle will be half pi r square. Like that. Circumference of the total circle is pi r. Right? Total it is 2 pi r. Then half of it will be 1 by 2 into 2 pi r means it's only pi r. So like that you can take the half. So only the half is what we call the semicircle. And if an arc, if the total length of the arc is bigger than the semicircle, if it is bigger than the semicircle, that arc is what we call the major arc. And if it is lesser than the semicircle, that is what we call the minor arc. What if it is just same as that of the semicircle? It's just called the semicircle arc, right? It's the half itself. Okay, no need to think about that one. These are the two typical things which you have to understand. Major arc and minor arc. Now we are going to find some equations regarding these things. These equations are very important. And let me tell you, when you are studying this chapter, there are plenty of equations to find the length of the minor arc, length of the major arc, length of the minor sector, length of the major sector, length of the minor segment, length of the major segment, area of that one, perimeter of the, there's plenty of things are there. But actually I will tell you a simple one which you have to understand. Just to focus on the major part or on the minor part. Any one of them, that's enough. But for easiness, I will tell you that you have to focus on the minor arc. If you're finding the length, you have to remember the length of the minor arc, area of the minor segment, area of the major, like that means everything minor segment, okay, the minor sector, minor arc. From that one automatically you will be able to find the major one also. So there is no need to study all the equations together and just make your head making into a problem, right? So that's very good that if you are just understanding this minor, that's enough. So from here, let me tell you, the first equation which you have to study is the length of the minor arc, the length of the minor arc. So if you are studying the length of the minor arc, from that one I told you, you can find the length of the major arc also. So length of the minor arc, length of minor arc is equal to, watch this one very carefully. We already know the circumference of the circle was 2 pi r. So it is 2 pi r into theta divided by 360. Theta is actually the angle measure. Whenever a particular sum regarding this chapter is given, definitely the theta will be, theta is the angle which is made, means it's the measure of the central angle. It's the measure of the central angle. Whenever you're taking an arc also, from that both the arcs, if you're joining two chords towards the center or two radius towards the center, the angle inscribed within this one is what we call theta. So every time the theta will be given. So keep this theta by 360 in mind. Actually, I'm taking like this. In other textbook, you can see pi r into 1 by theta by 180. You can see like that also. Actually, they cancel this 2 and 360 by the table of 2 and they made it as 180. You can do it like that. But theta by 360, I'm using this particular word again and again because when I'm going to explain to you the next topics, you can understand why I took this point. So the circumference into theta by 360 will give the length of the minor arc. Now you got the length of the minor arc. How will you find the length of the major arc? See, I will tell you. What about the total length of the arc of the circle? That is what we call the circumference of the circle. What is it? It is 2 pi r. So 2 pi r minus this minor arc. How much is minor arc is there? From the total, if you are subtracting the minor arc, the rest will be the major arc. Right? So from this one you can say the length of the major arc will be, it will be 2 pi r minus 2 pi r into theta by 360. Just subtract it from 2 pi r. That's all. So that's why I tell you, if you're understanding the minor, from that one automatically you will be able to find the major one. Now the next topic is what we call the sector of a circle. What is called the sector of a circle? So here you saw that this is a circle, right? With a single midpoint there. You can see this is the center of the circle. From the center, if you are drawing to radius, so the portion between these two radius and this minor arc, this is the minor arc, this is the major arc, right? So this is the minor arc and this is what we call the theta. Okay, that is the theta. So this one, this much portion is what we call the sector. something, just imagine that you are taking a pizza, right? Most of you might have had this pizza. So when you're cutting pizzas, you used to cut in this shape. So each piece of the pizza which you're taking out, pulling out, that's what we call the sector. It's easy to remember like that, right? So that is what we call the sector. And now, how to find the area of this sector and how to find the perimeter of the sector. So I told you this is the minor sector. What about this one? This will be the major sector. I told you what is a sector? A sector is the total space which is included between two radius and the arc. Included arc. So if you're considering this arc, this will become the minor sector. If you're considering this arc, this portion, this bigger portion, that will become the major, right? That will become the major sector. That's the difference. So let us go with the minor sector. So area of this minor sector will be equal to, I'm just writing simply like this, area of the minor sector. What is the equation to find the area of a circle? It is pi r square. So pi r square into theta divided by 360. Here it was 2 pi r and now it is area, that's why I took it as pi r square into theta by 360. So that from this equation you will find the area of the minor. What about finding the area of the major? Total area minus area of the minor, right? From the total area, if you're subtracting this much area, the area which is left will be the major area itself. So what is the total area? It is pi r square. So we can say the area of the bigger arc or the area of the bigger sector or the major sector is equal to pi r square minus pi r square into theta by 360. Like that you can find the area. Now the next one is the perimeter. Now I told you about area. Now let me tell you about perimeter. What about the perimeter of this sector? Perimeter means the total length, right? This much length. This one plus this much area plus this one. That's what we call the perimeter. So now tell me, what is this one? It is r. R plus r, it is 2r. So 2r plus, what about this one? This arc is what we call the minor arc. So r plus the length of minor arc will be the total perimeter of the sector. Now tell me, r plus r is 2r, we wrote that much. What about the length of the minor arc? Length of the minor arc, we already know it is 2 pi r into theta by 360. So here you can write 2 pi r into theta by 360 degree. So this is what we called the perimeter. This is how you have to find the perimeter of the minor sector. Now the next one is segment. Segment means, in the same figure I will show you where the segment comes. If you are drawing a chord like this, I'm taking it as AB. If you are drawing a chord AB, take the center as O. So here you can see there is a triangle also. This area within this one means the area included between these two, and this was what we called sector. The area between two radius and the arc is what we call the sector. Segment means this will be the area, this part. In the previous time I told you, just remember about pizza, right? But here let me tell you, if you just imagine that you are taking a cookies, a biscuit, okay, a biscuit of round in shape, and you are just making it two pieces, something like that. You will get a small piece, you will get a bigger piece. And that small piece is what we call the minor segment, and the bigger one will be obviously the major segment. Now this area, the shaded area, that is what we call the segment. Now tell me, how can you define a segment? The segment will be the area between the arc and a chord. Arc and a chord. So here obviously we can say this one, it's a minor segment. Now from minor segment you have to find the area of this minor segment. So area of minor segment, area of minor segment is equal to, how to find the area of this much part? See, from this one, if you know the area of the minor sector and if you know the area of this triangle, so area of the minor sector means the total area minus, from that one if you are subtracting the area of this triangle, definitely the left area will be the area of this part. That is what we call the minor segment. So we can say the area of the minor segment will be equal to, how you can mention that one? Area of the corresponding sector minus area of the corresponding triangle. triangle. Now area of the corresponding sector. What is the area of the corresponding sector? Here it is this sector. So how to find that one? It is pi r square into theta by 360, right? Minus, from this one what you have to minus? You have to subtract the area of this triangle. This triangle is having a specialty. What is the specialty of this triangle? It's already two sides, it's already known, both of them are radius itself. So we can say it is an isosceles triangle. But one thing is there, you know the angle measure of that angle also, right? You know the angle measure. So whenever a triangle is inscribed within a circle, the total area, or whenever we used to find the area of a triangle, there are plenty of methods. If you want to find the area of any triangle, normally we will use half into base into height. But here we cannot use that one because one degree measure is given, one angular measure is given there. So in this case, the area of such a triangles can be found by using the equation half into r square into sine theta. So we can write minus half r square. So these are the equations which you have to know. If you know this much equations very fast from this equation, you can come to the MCQ sections. So first of all, you have to study the equations very carefully. Now let us get into the MCQ part. So let us get into the very first question of the MCQ of the chapter areas related to circles. The first question is, the perimeter of the circle having radius 5 centimeter is equal to. The perimeter of a circle having radius 5 centimeter. So the radius is 5 centimeter. You know what is the perimeter of a circle? What is the perimeter of a circle? Actually, the perimeter means it is the circumference itself. I told you this is about 1 mark question, so I am not using the pen or pencil or anything. Let us try. Without using those things, if you are able to find the answer, that's great, right? So here goes the question before you. Now from this question, it is very clear that the radius is mentioned. It is 5 centimeter. And you have to find the perimeter. That means you have to find the circumference. The equation is 2 pi r. 2 into pi into r. What is pi? It is 3.14. So 2 into 3.14 into 5, because here r is 5. So tell me, 5 2s are 10. So 10 into 3.14. 3.14 into 10. Means whenever you are checking a decimal number, and if you have to multiply by 10, rather than multiplying it by 10, what you have to do, you have to take the decimal point and change it to one place towards the right. So that 3.14 will become 31.4. So the answer is 31.4. See, we didn't use our pen or pencil or anything. Without using anything, you got the first one's answer. That's the way. If you're using for everything, don't go behind the pen and pencil. Don't go starting doing mathematics. That means there is a question, then there is a problem. You have to solve it. Where is the pen? Take the paper. Don't go like that. There are some easy things. If you're understanding those things very perfectly, very fast, you can understand maths. You will get the solution, and maths will become an easy thing for you also. So here, the answer for the first question is 31.4. And without using the pen, we got the answer. That's great. Right? Now let us go to the next question, question number 2. The largest triangle inscribed in a semicircle of radius r. Then the area of the triangle is. So there is a semicircle. Let's draw it, right? There is a semicircle. So that is the center of the semicircle. And one thing is very clearly given. What is given there? The radius is given. It is r. Okay, this is the radius. From here to here, it is r. Now, what is the question? If you are inscribing a triangle inside the largest triangle. So whenever you are trying to draw a largest triangle within this one, if you are trying to draw a largest triangle inside this one, definitely it will consume all the base area and it will come like this. It will be like this. This will be the triangle. Okay. So you have to find the area of this triangle. What is the equation to find the area of the triangle? It is half BH, half into base into height. So what about base and height? If you know base and height, you can find the area of any triangle. So tell me, what is the base of this one? This is the base, right? Just take it as AB. So AB is the base. You know from A to O, this is the center. A to O, that is the radius. From O to B, that is also the radius. So radius plus radius, it is 2R. So we can say the base is 2R. So half into base into height. Half into what is the base? It is AB. The total length of AB is 2R. Half into base into height means this is the height. Actually, this is also the radius, right? That will be also the same radius. So we can consider it as R itself. 2 and 2 will cancel. r into r is r square. So the answer is r squared. So like this you can find it. So that's it, and that's the answer of the question. Answer is r squared. Now next question. The area of a circle that can be inscribed in a square of side 10 centimeter. Means there is a square given. Just imagine in your mind a square is given. The total length of the square is given 10 centimeter, means each side will be 10 centimeter each. You have to draw a circle. That means a circle should be inscribed inside this triangle. So if you are drawing a circle within this one, definitely it will be something like this, right? And now what is your task? You have to find the area of this circle. I told you, whenever you want to find the area or anything regarding a circle, circle is having only a single dimension, that is its radius. So the main thing is you have to find the radius, means from the center till here. This is actually half of this one, isn't it? Altogether, if it is 10, from here to here, definitely it is 5 centimeters. So you got the radius is 5 centimeter. Now, what is the equation to find the radius of the circle? Pi r square. See the options here. What are the options given here? 40 pi, 30 pi, 100 pi, 25 pi. So everything is in pi. So there is no need to substitute the value of pi. Just speak it in pi itself. Just give it in pi itself. Tell me, so how much pi the total area is? So the equation to find the area is pi r square. Now the r is 5. 5 square means 5 5 is 25. So 25 pi. 25 pi. Is there that option? Yes. The fourth option, 25 pi, is the answer for this question. You got it. So here goes the next question before you. The perimeter of the sector with a radius 10.5 centimeter and the sector angle 60 degree is. That means you have to find the perimeter of the sector. Perimeter of the sector. This is your sector. Perimeter of the sector, this one. Perimeter of the sector. Okay, you know the equation. So that's why I told you initially, you must know the equations very good. Now the equation is there. Perimeter is equal to 2r plus 2 pi r into theta by 360. What is theta? It is 60 degree. What is r? It is 10.5. It is 10.5. So the radius is given. So let us come one by one. So the perimeter P, you have to find P itself, right? So see how we are doing, because this is not about a 4-mark question or not a 3-mark, it's just a 1-mark question. You have to deal with the MCQ portions. So in a fraction of a second, how much simply you can make the answer. That's the very important thing which you have to understand. So perimeter P is equal to simply, from there 2r means 2 into r. What is our r here? It is 10.5. So 10.5 into 2 into 10.5. The twice of 10.5, how much it is? 21. Whenever you have to multiply by 2, just find that twice, that's it. So 10.5, the twice of 10.5 is 21. So you got it, 21 plus, that much is over, 2r is over. 2 pi r into theta by 360. What is theta? It is 60. So 2 into, so here regarding pi, there may be a confusion that whether you want to take 22 by 7 or whether you want to go with 3.14, because in the previous question we went with 3.14. So here actually very wisely you have to choose that one. See here, you know that already 21 is there, and you know that 10.5 is the radius given, and 10.5 is divisible by 7. 10.5 is divisible by 7. Keeping that in your mind, as it is divisible by 7, obviously you have to take here 22 by 7, because it comes inside the table of 7, right? So that's why we are going to that way. So 2 into, instead of pi we are going to write 22 by 7 into, tell me, 2 pi is over, r is 10.5 into theta by 360. What is theta? Theta is 60 degree, it is given. So 60 by 360. That's equal to 21 plus, here 7 and 10.5 you can cancel, 7 ones are 7, here 7 ones are 7 point, then 3 is remainder, 35, 7 5s are 35. 60, this 0 and 0 you can cancel them together, and 6 and 36, 6 ones are 6, 6 are 36. 2 and 6 you can cancel, 2 ones are 2, 2 3s are 6. 3 and 15 you can cancel, 3 ones are 3, either here you can write 3 5s are 15, but point is there, so point will be there. Now what is left there? 122 into 0.5. 22 into 0.5. What is 0.5 actually? There is no need to multiply. I will tell you. What is 0.5? It is 1 by 2. Half is what we call 0.5, right? 11.5 means 11 and a half. 1.5 means 1 and a half. So 0.5 means half. So 22 into half means half of 22. Tell me, it's 11. So now tell me, 21 plus 11, 21 plus 10 is 31. 31 plus 1, 32. So 32 centimeter. That's the perimeter, right? So you got the answer. So then in fraction of a second, just by taking that equation and just implying that wherever you need just to substitute the values, you will get the equation. You will get the final solution. So there it is. The answer of this question is 32 centimeter. So here goes the next question before you. In a circle of radius 21 centimeter, an arc subtends an angle of 60 degree at the center. The length of the arc is. You have to find the length of the arc. What is the equation to find the length of the arc? Length of the arc. 2 pi r into theta by 360. That means if you know the radius and if you know the theta, you will get it. So see there, focus your eyes on that equation, length of the minor arc. You are going to find that one. What is the thing given here? Theta is given. It is 60 degree. So let us do the last portion. Theta by 360. 60 by 360. Cancelling 0 and 0. 6 and 36. 1 by 6 will be there. Keep that in your mind. Only 1 by 6 is left there. Okay. That much is over. 1 by 6. Now 2 into pi. Pi is 22 by 7. So 2 into, let's do it. 2 into 22 by 7 into radius r. What is the radius given here? It's 21. Into last portion theta by 360. I told you it is, right now it is 1 by 6. Because it was 60 by 360. Cancelling 0 and 0, 6 and 36, you got 1 by 6. Now from this one tell me, 7 and 21 will be cancelled. This will become 3. 3 and 6 will get cancelled. 3 ones are 3. 3 twos are 6. 2 and 2 will get cancelled. Finally, what is there left? Only 22 is left, right? So we will say this 22 is the answer. So you can say 22 centimeter. That's the answer. So actually how to find this one? If you know the equation, from that equation, whatever things are given inside the question, whether they are known or not. If you want to find those things, then you have to use some equations and then you have to go behind those things. But here you can see that very straightforward those things are given. So this is all about this chapter. I hope you understood the MCQ parts. These are the main questions which are expected to come from this chapter. So I hope you understood, you enjoyed the class. So this is the way how to understand the MCQ part and do it within a single minute. That's very important. The time consuming is so important. So I hope you will understand these things and keep on practicing so that your speed will increase and you will never waste any time sitting inside your examination hall. So that's it for today's class. We'll meet again in the next video with a new chapter. Till then, take care and goodbye. Hi dear students, welcome back to the section of mathematics of class 10. Today we are going to deal with the MCQ part of the chapter triangles. So dear students, in this chapter actually we are going to deal with two things. One is about the similarity of triangles. The other one is the basic proportionality theorem. You know that inside this chapter, the portion of areas of triangles is already removed for this year. So we are not going into that section. We are just keeping into this particular topics and we will be discussing about that. So this is very important that you have to know some particular theorems regarding this one. If you understood the theorem behind this one, that will give you the easier way to get into the solution for each problems within 1 minute. That's our motto, right? So let's go for it. First of all, let me tell you what is the similarity of triangles. Two triangles are said to be similar. Okay, if two triangles are said to be similar, you already studied in your 9th class about correspondence, right? Corresponding triangles, congruence and all these things. So in this chapter, we are going to deal with similarity of triangles. When you're dealing with similarity, the only thing which you have to keep in your mind, see, just if it is said that two triangles are similar, just take two triangles ABC and DEF. Most probably we used to take like this. This is the symbolic representation of like this. That is a symbolic representation of a similarity. So if two triangles are said to be similar, if they are said to be similar, it means that the corresponding sides, the ratio of corresponding sides should be equal. That means ratio of corresponding sides means AB by DE, this one AB. So that is the first term, right? If you're taking the first two sides, that means this side AB, corresponding side is DE, right? That is the corresponding side. What about the other one, BC? This one, the corresponding side is EF. What about AC? It is DF. So all these three sides will be having the corresponding sides of these two triangles will have the equal ratio. They are corresponding sides will be in the same ratio. Keep that in your mind. And also one more thing, this angle A should be equal to D, and the angle B should be equal to angle E, and angle C should be equal to angle F. So this is the condition regarding the similarity of triangles. There are different theorems regarding this one, supporting this one, AA similarity, AAA similarity, SAS, like that. There are plenty of theorems. Keep that in your mind, leave that behind, because we are dealing with only 1 mark questions. So in a capsule method, I'm going to define what it is. So keeping this much in your mind, let me go to the next theorem, which is called the basic proportionality theorem, or that is also called the Thales theorem. This is very important here. And the proof of that one is very important, but we are only dealing with the MCQ section. That's why I'm just giving you. See here, if a triangle is given, okay, if it is ABC, just imagine that XY, it's a line segment which cuts this AB at X and AC at Y. And one more thing is very important. Inside this one, the main thing given is that this line is parallel to BC. They are parallel to each other. Means that line is parallel to the base. Don't think that even if I draw on the center, almost on the center, don't think that this is the midpoint. It may be or it may not be. That is not the condition. That's not the relevant condition. The condition is that the line whichever cuts this AB and AC, that should be parallel to the base. That's all. So if this is parallel, keeping that in your mind, if these two lines are mentioned parallel, then the condition is, the theorem behind this one is AX by XB will be equal to, here AX by XB will be